What's up, everybody? This is Matt Brown with another IoT hacking video. Today we have yet another Chinese security camera, and we are going to be looking at some of the network traffic that this device sends back to some of its cloud servers and begin our analysis of this device. Usually, I would start with a bit of hardware hacking. I've just had the box here because, as you can see, I have the device in pieces over on the desk. But sometimes I like to start with hardware hacking, and other times I will start with network analysis. It just depends on how I feel that day. And so today we are going to begin by analyzing some web traffic from this product right here. This is a Anran solar battery camera thing. I definitely didn't pay that much for it. I bought this on eBay. And so all these wonderful features. I love how in bold they mention here how you cannot add this to a network video recorder, which, just like a weird point about this is not super important, but their website is Anran-CCTV, closed circuit television, which you would think would indicate that you can add it to a local only network video recorder, but I digress. That's not important today. What is important is how we're going to capture the traffic that this device sends out to the internet. And if you're new to this channel, you will be new to this tool. If you're a longtime viewer of the channel, you'll know that we're going to use my trusty tool, man-in-the-middle router. This is not some amazing tool that I've written. I'm really just duct taping together a couple different open source Linux utilities, and then we have this fancy diagram here which explains what's going on with man-in-the-middle router. And today, this camera that we're targeting is a Wi-Fi only camera, which is the benefit of this system as I've laid it out. Here, the bash script that sets up this whole environment for testing allows IoT devices to connect to the testing network via two different ways, via Wi-Fi or Ethernet. So today we are using this wireless interface, which is created by HostAPD. HostAPD is an open source Linux utility for creating access points. Oftentimes, your home Wi-Fi router under the hood is just using HostAPD. And so that is going to be connected to a bridge interface, which we also call the Bro interface, BR0, and it is going to hand out IP addresses using DNS mask as the DHCP server. Then we are going to be able to perform packet captures on that bridge interface to see what's going on, the traffic back and forth between the cloud. And the second step that we're going to do in this video is we're going to perform a man-in-the-middle attack on the traffic between the device and the internet, and we're going to attempt to do a man-in-the-middle attack where we present ourselves as the cloud server and say, hey, here's my certificate that you definitely should trust. Not really. And then it is going to either deny that connection or accept it and send us data. So we're going to do that as a step 2 in this process, and we'll see what happens. So let's get started. We got Wireshark ready to go. Right now, I don't see that BR0 interface because I have not ran man-in-the-middle router yet. And so what we're going to do is we're just going to take that shell script and then we're going to pass the up parameter to it. By the way, that tool, I will have the GitHub link to man-in-the-middle router in the description of the video. So here we can see that it says it has an AP that is enabled on this wireless interface. And so now what I'm going to go and do is start monitoring traffic on that interface. And then I do need to just go over to the desk here. This is kind of in a state of crazy because I'm doing some hardware hacking, but we're going to hold this button to power on the device. And I'm kind of just like looking down below at some lights that are blinking to see that it is actually turning on. And it's kind of hard to see the status of those lights because they're underneath the camera in the way I have it set up. Okay, I think I have to gotta hit it again. Okay, there we go. Now we're blinking. And actually over here, what we should also be able to see right there. So we see these messages that we got a connection. So now we see traffic over here in Wireshark, which is great. So we can scroll up and see some of the first communications when the camera connects to the wireless network. The first thing that it's going to do, well, this is this weird packet, but we don't care about that for now. The first thing it does is it sends out a DHCP request. It says, hey, does somebody want to give me an IP address? And then our DHCP server says, we would gladly give you an IP address of, this 100.21 address is our device. And then we get a whole bunch of other stuff that's going on. We get this connection, which I'm going to look at maybe in a future video. I don't think there's a whole bunch here, but this is an interesting part here. I'll look at it really fast. And so this is a binary protocol that just kind of springs out here. Let's go TCP stream, and notice it it fires off. Ooh, this is something different. Okay, we're gonna have to dig into this. This is a lot simpler last time. So yeah, we can just see some binary protocol messages going back and forth there. So I'm gonna hit back, and that will clear the filter. And here we're seeing some DNS requests for APIs, US West, CloudEdge360.com. So this is one of the main cloud servers that I've seen this device communicating with, and of course it does a DNS query for it. And then we see, okay, so it's having some problems getting to the DNS server, and then it finally gets there, and it makes a TLS connection to that server. So TLS, if you're not familiar, or like it used to be called SSL, some people still call it SSL, is the most common encryption protocol that is used to encrypt traffic data in transit on the internet. And so this first message here is our device, you see the local IP, calling out to this cloud server, this public IP, and it says, hello, I would like to connect to you. And so if we go ahead and right click, and we can say follow TLS stream, this window is not going to be important. It will show us all the messages that go back and forth in the TLS layer, kind of. So we see the client says, hello, I'm here. The server says hello back, they're having a good conversation here. And then the server hands the client a certificate. So this is important here. So certificates are how a server identifies itself and proves that the server is who the server says it is, right? That it is, in fact, APIs uswest.cloudedge360.com. That it is actually that server and not an attacker's server that is pretending to be that cloud server, right? How does it know? Well, this certificate, let's go ahead and actually look at the certificate here. So we can look at these different parts of the transport layer security message here. And so we can dig into the certificate here. And we go down in the handshake, certificate, and we can see actually that 3 certificates are provided. So this is interesting. Let's look at the first one here, and let's go into the signed certificate. And I want to find, okay, the subject right here. So we can see that there's a certificate star.cloudedge360.com. Okay, so that is the common name. That is the identity of this first certificate that we got passed. Now let's look at this next one. We're going to dig into the subject. Okay, and so here we have an intermediate kind of signing certificate here. This is a GoDaddy, secure certificate authority. So GoDaddy has signed this wildcard certificate, that star dot, cloud 360, whatever that thing is. And then what I assume, let's go look at the one other certificate here. And this should be the root certificate. So going to subject. Yeah, so GoDaddy root certificate. So there's a root, there's an intermediate, and then there's that wildcard certificate. Yeah, let's go back up and look at that one again. That star.cloudedge360.com. Now, that chain is good, right? As long as the client is actually doing its job. Once the client receives those certificates, what it should do is it should have hard-coded like into its set of trusted certificates. Certainly this GoDaddy root certificate should be in that set of trusted certificates. And then it needs to go up the chain and check the signatures to make sure that they are all, that the server certificate is signed by a chain that chains down to the root. And if it's not, if the signature is not valid, it should reject the connection, right? And here, obviously, there's no man-in-the-middle attack going on, and so it does go on and accept the connection here, and then we see application data. Application data means like that's the encrypted data that you actually want to send through the encrypted pipe being sent. But is the device actually validating that this certificate is legit? Let's find out. So now we're going to go into that step 2, right? So we've observed some of the traffic. Oh, by the way, there's also some clear text HTTP that gets communicated. Let's look at that really fast. Oh, it hasn't communicated it yet. That's so funny. All right. Sometimes I have to like wiggle the motion thing on here to get that to fire. That's fascinating. Okay. All right. At least right now, it's all that encrypted stuff. All right. Let's go ahead and I'm going to hit stop here. And I'm actually going to Control C. And I'm going to go here. And I'm going to vim our man-in-the-middle router script. I'm going to edit it with a text editor. And I'm going to go down to the bottom here where I kind of have these commented out optional man-in-the-middle rules. They're just IP tables rules. I'm just using other open source tools to do this stuff, right? Nothing fancy. So right here, what this IP tables rule is going to do when we uncomment it and we're going to run our whole router script again, is it's going to set up a rule that when it sees traffic going out to a destination port of 443 out of the bridge interface, it is going to redirect it locally to port 8081. And we are going to run man-in-the-middle proxy on port 8081. We're going to do -K, which just means when I go upstream, it's not going to do a certificate check. I don't care about that. And then for the mode here, we're actually going to proxy it one step further, and we're going to proxy it over to Kaido. And so I have Kaido running on port 8080 right here. And so we're going to intercept the traffic in man-in-the-middle proxy, and then it is going to in turn proxy it over to Kaido. And the reason we're going to do it in Kaido is because Kaido is just a nice interface to be able to like modify and resend packets or HTTP messages. So, all right, so we're going to go ahead and run our man-in-the-middle proxy here, and then we're going to save our man-in-the-middle router script, and then we're going to say up. And then is Wireshark gonna, no, it's not gonna yell at us because we stopped it. Okay, so we're gonna start this over, and then I'm gonna turn the camera off. It's like a long button hold. Unfortunately, I can't just like pull power because it's battery powered. I guess I could find the battery connection. Okay, I got a flash. The easiest way is to just watch here, actually. to see when it connects back to the Wi-Fi, and it has. And here we go. And I'm gonna actually like move this camera around to try to like trigger the motion detection, because I feel like that gives me more packets when I do that. This is very non-scientific. I can take all my probes off of this actually, so I'm not probing UART right now. Okay. Yeah, it's fascinating. There used to be clear text HTTP. I wonder if it like silently upgraded the firmware in the background. But here we can see in man-in-the-middle proxy, it has gotten requests. So this is excellent, and this is proving that the client, i.e. the IoT device, is not validating the certificate that the server is sending it. Because what man-in-the-middle proxy does is it forges a fake certificate, right? It says, here's this star dot, cloud 360, whatever that domain is. It creates that same cert, and then it signs it with a man-in-the-middle proxy root CA certificate, right? Because it doesn't actually have the keys for the GoDaddy certificate to like legitimately sign the chain, right? So it has to just sign it with a root cert that's hard-coded into man-in-the-middle proxy, right? So, but we have intercepted, and we can look through it here. We can look through like the stuff here, but we can also see that we have it over here in Kaido, which is cool. And it's just an easier interface to replay stuff. And so if we look here, the first request that we've observed is one going to that API server, and it's doing /v12 devices binding state. And so it's like getting the binding state of this device, right? And so it's sending this license ID, which is effectively the device ID. And what's interesting here, and I said at the start of the video, sometimes I start with the hardware hacking and it leads you to doing stuff over the network. Sometimes you start in the network and it leads you to hardware hacking to answer questions. One question I have that I haven't figured out yet is how authentication is working. Well, I do kind of know how authentication was working. It has to be this right here. So this message is most likely being, it's being hashed. Most likely this whole HTTP message is being hashed, and then the signature, minus this header, right? Or maybe it's just, the host header. Who knows what the scheme is for performing a signature on this message. But we can see here that there's this, XCA sign, and there's a nonce that's probably involved in this process. It kind of smells like digest authentication, but it's not. It's clearly not digest authentication, but it looks like it, where there's a signature that's being performed on the HTTP request, some parts of it. And so if we send this to the repeater, right? So I can take this message and I can resend it, and I get that response back. But like, let's change the nonce. So I just change that 2 to a 1. I don't get back the other response code, right? If I go back here, well, the result code is the same, but I'm not getting this T value. So I assume that means that the request really wasn't accepted. But I need to learn more about these requests and responses and how this response gets parsed. And to do that, we're going to need to do some hardware hacking and pull the firmware off. So we're going to be looking for that in the future video. And in that future video, we're definitely going to be doing like string searches through the firmware for these headers to know how those values are used and how they're generated by the device. Since it's the device that sends this request that has this data in it. So there's some other stuff here. There's this like post of Bell, v13 active, and there's this like JSON blob here, which we can, we can like go look at this. Is that, I don't think that's URL encoded. I think I just do that. Yeah, here we go. So this is like all of these characteristics about the device. It's on version 91, whatever that is. There's some other information about like the camera resolution, right? So there's a bunch of properties that are being sent to the server. It's like the capabilities parameter, right? So we can see the same form of authentication though, right? That's being used. This XCA sign value is most likely where the authentication is being sent to the server. And we have another request to a completely other system, which is this miaricloud.com. And so similarly, man in the middle works on the communications to this domain as well. And so OpenAPI device config. So it's like, I don't know, it's like sending some parameters here. Obviously this is like JSON. I don't know, we can just like look at this. Let's just copy that. And send that there. Okay, so whatever, it's just encoding some benign data there. And it gets back something from the server. So that's pretty interesting. Obviously, again, the similar signature is being done, but what's interesting here is it's in the get parameter. You see that? So there's this like signature that's happening in the get parameter. So I can resend this. I get back data, right? I realize my like face is covering that a little bit for you guys, but you can see it. It's returning data. But if I change like the device ID to like something else, right? Like, and I try to send it, it's probably silently failing there, even though the code is the same. I wonder if I could, figure out another valid device ID. I don't think these device IDs are sequential, or maybe it's computed based on the MAC somehow. It's not exactly the MAC address of the device, but this is all stuff that we could guess at in a black box way here, or we could go and figure it out from the device. And so that is going to really guide some of our hardware hacking to figure out what is going on there. And I just want to go, wow, maybe it pushed a firmware update on me, because this device was definitely sending some clear text HTTP before, but I don't know if it just updated or there's a certain circumstance under which it will send that data. But we still did the man in the middle attack like I wanted to show you guys. And so in future videos, what we're going to do again is we're going to maybe see if we can interact with the UART interface. You could even see I had like probes set up. I was trying to find that today. And then there is a flash chip also that is going to contain all the firmware. So we're going to pull that flash chip off and see if we can get insights into how those requests are being authenticated, how that signature header is being generated, and see if there are any weaknesses in that authentication scheme. So thank you for watching this video. If you like this content, if this is something that's interesting to you, this style of content, please hit subscribe. That's the biggest thing you can do to help the channel. Comment, let me know what you thought, and as always, have a good day.